Hello all. In this video, we will discuss about application interface or API, web services, microservices, and batch process. So these are a part of the course which I drafted named Systems, which will give business analyst and scrum master technical knowledge, and it will help business analyst and scrum master understand what the developers are and testers are telling them. At the same time, it will also help business analysts and scrum masters to convey message and talk to developers and testers in their language, which is technical language. So systems will give you that lens or that medium to communicate with the technical team. And in today's video, we will go over batch process, application interface, web service, and microservice. Please do hit the like button and subscribe button and like this video and share it. Let's go to the training. So now we are talking about API. It's called application interface. The full form of API is application interface. Now, so why do we use API? So let's say, for example, we will take an example of Uber or Lyft, right? So when you open the Uber application, when you click on the right, you'll see a Google map. And they have also customized that API. So they have also, so wherever the car is, you could actually see it in the map, wherever they are driving. That part also, you can see it. So that Google map itself they don't own it. They are actually borrowing it from another application. They are borrowing it from another organization or another application. They are borrowing it from Google. So they are using a feature or a functionality or a component or an epic. I would call it an epic, right? Because it's a big map and it has a lot of business logic behind it. So they are using that map from another application, which is housed in another organization. So that is where API comes in. So using the Google Map API, you could use that component or you can use that feature coming in from an other organization. So when this happens, Uber and Google will have something called SLA, service level agreement. So how will they get mutual benefit? So maybe every time there is a hit, Google might get paid. Every time there's going to be a ride, Google will get a certain percentage, because without that map, they can't do it. So we don't know what's exactly in the SLA, service level agreement, but then there's most definitely going to be a service level agreement in place. So what is another example of another good example of API? Another good example would be PayPal. So PayPal API, right? So you might have, even in if you want to purchase something, it could be some sort of a furniture selling application, or even I've seen in some training centers, they have that PayPal feature that in their application. It's not PayPal application, so they'll be able to take payments via PayPal. But that's not PayPal application, right? But that feature itself, where you could actually send money instantly, belongs to PayPal. Now, but then you can see this feature across multiple other applications. So that's possible through, again, API. You could actually borrow the same component or an epic from another application and use it in your application and have a service level agreement in place. So any questions on API? So every time you see something like weather or a map or PayPal or something like a Zelle in another application where it's not supposed to be, I would not say not supposed to be, but then it's not a banking application, but then you see PayPal. Or if it's another application, even for some other websites also, you can see the Google map in that. Then you could always assume that there is some sort of an API gateway. There is an API involved. So that's where API comes into the picture. So the next concept is, so this is API. So the next concept is ETL. Now I'm going to give an example of something that happened in my project itself. So there was a page, and the page is named factory information page. So the name of the page was factory information page. We had to build that page. Okay. So all the information of the page will be stored here in the factory information page. All the information will be stored here. And we built this page in 2019. Okay. So we built this page in 2019 or something. But then after that, they started entering all the factory information into this page. Where is it located? Address, unique identifier, governing body information, all this information, irregularities present, complaints history, number of workers present. So all this information, all the information is documented here in this page. Right. Now, before this page was built, what were they doing? They did not have factory information page, right? But then they have to somehow document the factory information. So they did it using something called SurveyMonkey. So they'll go there using SurveyMonkey. It'll have all those questions. I'm sure you might have seen SurveyMonkey at some point. It'll have all the questions, right? So they'll document everything. And once they document and hit submit, the data is going there and getting dumped into an Excel source. So it got dumped into an Excel source. And we got that Excel source, very large document, a lot of entries present. They are doing like this for a period of 2 years. Because building that page was not priority. Building the factory information page was not priority. Now, once we built the factory information page, when it comes to all the new entries, they can always enter it here. But what about the entries for those 2 years? It can't just keep sulking in that 2 years old, in that Excel source, right? It can't just keep staying there. So we had to migrate it into the, so if data must be displayed in this page, it has to come from an Oracle database, correct? So if the data must be displayed in the factory information page, it has to come from an Oracle DB or a SQL Server integration services database. I'm sorry, a SQL Server database or some sort of a database. So now it has to come from a database. So there is the Excel source which has the 2 years of information. So what will we do? We will do ETL. We'll extract the data. We'll transform the data. So now Excel might have, okay, I'll just say this first and then explain the transformation part. So we'll extract the data out of Excel. We'll transform the data so that it's conducive to be put in a page, right? And then we'll load the data into the Oracle DB. So we'll create a table in Oracle DB even before the data is migrated. There will be a name for the table. There will be a name for the columns, which I did everything. And even the data type, char or varchar and all that I have to put in. Even the developers used to help me. If I do it wrongly, the developers will correct me. So it wasn't a big deal. So I'll just do that. So this will be where the data will be landing. So they'll extract it, they'll transform it, and they'll load it into this table inside, which is inside the Oracle database. And this table will drive this page. Each and every page that you see in each and every application is driven by a table or a set of tables, driven by a database. Now, let's come back to ETL. So what is happening? Extraction from the Excel source. So this is the Excel source. Transformation, okay? So what is happening in this transformation part? Now in Excel, there were some entries where they did not enter the unique identifier of the factory name. So that is not a good entry. We have to remove that. Correct? We can't just put it in the page without factory name, without that unique identifier, that unique number that they'll have. Without that, you cannot document any other information. It won't make sense. That page won't make sense, right? There is a factory information page. At least it has to have a unique identifier and then the name of the factory. Without that, you are saying 10 staffs are working there, 5 machines are there, but then name is missing and then the unique identifier is missing. That's not a very good way to document and house information, correct? So that's where transformation is coming in. So all these entries will be weeded out and it will be put into an exception report. What is an exception report? It is not something that's very complicated. It's just an Excel file that has all the entries that are like this, that are bad data. So the business will look at this exception report and then they'll say, okay, if the data is like this, if the name is not there, that is okay. As long as there is a unique identifier, we can put it into the application. Then it will come back into the stream. In the case where there is no unique identifier, that's it, lost cause. It's just scrap. So this is transformation. And what is the other kind of transformation? First name. So let's say, for example, we are extracting data. The data has SSN number, right? It's very, very, it's a very sensitive information. If you give your SSN number, first name, last name, date of birth, they can actually get a loan for $10 million and make you liable for it. If you don't have very good legal team, you could actually end up in trouble. Okay. So I was a victim of identity theft, but then they did not take loan or anything. They booked an apartment under my name. Somebody was very kind and they did that. But then coming back, so let's say SSN will have how many numbers? 9 numbers. So I'll just put 7, 8, 9. Okay. So now in the source, SSN has 9 numbers, but this is a very sensitive data source. Now when we extract it and when we transform it, we don't want the first 5 numbers. We just need the last 4 digits because maybe that's just how they maintain complaints. This is very sensitive information. So we just put the last 4 digits. This is called transformation logic. And then we'll send it into the destination. This is called transformation logic. So in the source, there is 9 digits for SSN. We extract it. We transform it. So the 9 digits become 4 digits, the last 4 digits. First 5 digits we are not taking out, and then we are dumping it into we are loading it into the destination, D for destination. So this is extraction, transformation, and loading. We are extracting. As a part of the transformation logic, 9 digits must change to 4 digits, only last 4 digits. And then we load into the destination location. This is just one transformation logic. You could take out all the middle name. So there are multiple other transformation logics. Maybe there is around profit from, so let's say there is a bookstore. There is profit from history books, profit from science books, profit from journals. But then as in the transformation logic, you could just put, just give me the net profit. So it will just add those columns up and then it will transform it and then it will load into the destination source. So that you can come up with a lot of other examples. But then this is called ETL, extraction, transformation, loading. Any questions? Someone talking? Am I not able to hear someone talk?
No, nothing.
Okay. Now, what are all the tools used for ETL? Okay. What are all the tools? So this is something, ETL is something that happens a lot, but no developer will come to you and say, hey, I'm doing ETL. Nobody will say explicitly like that. They'll just do it themselves. They'll be doing it in their end. Okay. Just like I said, even in that Excel source example, this actually happened in my organization. They never said, okay, we are going to do an extraction, transformation, and loading. They will not be doing all that. They'll just say, if there are any bad entries, I'll do a exception report. I'll give it to you. Go and ask the business whether everything is scrap or we can put some information into the stream. So I'll go and ask the business. They'll say, okay, these entries can be brought into the stream. These entries can be dumped. So entries which has a unique identifier can be brought into the stream. Entries which has no first name entries with no unique identifier they are scrap. Entries with names not present, they can be brought into the stream because anyway they have some sort of a unique identifier, so we can figure it out. So this is exception report on how they are going to handle that. So this is what I do. I'll go and ask the business what can be done. At the same time, I'll also write the transformation logic. But no developer will come and say, okay, I'm going to extract, transform, and load. They won't be using all these textbook terminologies. It'll all be happening inside. But then if you understand this concept, then you'll understand, okay, this is what they are doing. Even though they won't say it explicitly, you'll understand that this is what they are doing. And then when you go and interact with the clients, you will be able to interact properly. Otherwise, it will be kind of difficult, right? So now, what are all the tools used to do ETL? Now, ETL might look like a simple process, but then there are specialized developers for ETL. They are called Informatica developers who specialized in Informatica tool. You might have heard of it. Another tool is by Microsoft, SQL Server Integration Services. Their prime, there are something called migration project, right? And there's a lot of migration projects in the market. So their prime responsibility is to move data. And when they move data, all they do is ETL using SSIS or Informatica. There are many other tools. These two are majority. They'll use Informatica. Many clients use Informatica. Some of them use SSIS. You have to be when they say, okay, when they say Informatica, you have to know that it is ETL tool. When they say SSIS, you have to know that it's an ETL tool. So that much familiarity you must have. It will have some brain behind. It will have a database. It will also have some business logic, which is brain behind. So web services will simply go and interact and come back. So let's say, for example, if you want all the flight details, it will just bring it to you. But then API, theoretically speaking, they'll say that it has business logic and then it has its own database. But then for understanding purpose, this is how I am understanding it. So in SOA architecture, I understand it to be monolithic application, meaning if this is the application, so this is front end, this is middle tier, this is back end. Okay, the code for the middle tier, the front end, and the database, they are all stored in one location. So they are all housed, they are all stored in one location. But in microservice architecture, that's not the case. They are stored in multiple locations. That is the difference between SOA architecture and microservice architecture. So SOA architecture will look like this. So this is the UI and this is the front end, this is the middle tier, and this is the back end. So all the code is stored here. Just think of it like this. So all the code is stored here and it's projecting this. So the code is stored here, it's projecting this. So even for this, so this is all the same, right? So for these two, it's just stored here. For a database, I'm just thinking it's stored kind of separately, but then it's all stored in the same place. So this is SOA architecture or monolithic architecture, monolithic. But then in microservice architecture, so this is the front end. And then the code is stored in multiple locations. For the middle tier, code behind common code, it's stored in multiple locations. Think of this as middle tier. These are all middle tier. That's where the code is stored. and these are all database for each and every. So there are multiple database. So this is microservice architecture. So these are all separate databases housed separately. These codes are all stored in separate locations. And in microservice architecture, in the place of web services, microservices will be there. And the difference between web service and microservices, the activities are the same. It helps in interaction between two applications. But then one difference between microservice and web services. So microservice has some business logic built into it, and it has its own database. It's not the case for web service. They don't have any brain behind. But the activities that they do is same. Another difference between web service and microservices. Now say for example in web service, so this is one difference. The business logic and the database, and then the microservice architecture, how the code is housed. So it's different, right? So that's one difference. Now, another difference is, this is a very important difference. It can come in an interview too. Scalability. Meaning, so in the case where this is application A and application B, and what will web service do? It will help in the interaction between these two applications, right? Even if 100 people are doing that, the web service itself is not scalable, meaning it will not make itself into two web service and then do it. If many people are stimulating it, it will crash. But then microservice is scalable, meaning if 100 people are 100,000 people are actually triggering that, or all booking for the flight, or they all need some information and applications are interacting, the microservice will multiply. It is scalable, and then it will reduce. So it's kind of scalable. It can digest a lot of volume, a lot of usage, a lot of noise. So that is another area where microservice is different from a web service. Any questions?
No.
Okay, so that is microservice. So the next concept is called batch processing. Okay. So now say for example, there are two applications. Application A and B. Okay. So let's assume this is factory. This is the application that the factory management use. Let's assume this is the governing body. Okay. This is government. So this is governing body. So this agency regulates all the factories. Okay. So now, so this is an application A. This is application B. Okay. The factory management is going to report that they'll report every week. They'll report if there's going to be any workers who got injured, they'll report that. So they'll just put the name of the worker here. Okay. So every week there's going to be 100 entries. So every week, it's a very big factory. Every week, 50 or 60 workers will get injured. I'm just coming up with the rudimentary example. Or some workers will leave. Okay, let's say some workers will leave the organization. They have to enter it here. So every week there is going to be 100 or 200 entries entered in this application. Now the governing body, as per regulation, must be aware of all these things. Why are the workers leaving? Are the safety standards maintained or not? What is the reason? So they'll be regulating these factories, right? So what will happen? They need that info. So every week on Sunday at 12 a.m., a batch will run that will take all the information of number of employees left, number of staffs left, and bring it into application B. There might be 100 or 200 entries. Every week at 12 a.m., the batch will run. A process will happen, and that process will bring all the information here into an other application. So this is called batch processing. This can happen between two applications too. So whenever there is a case where they'll say every day at 12 a.m. we'll get all the info populated in this table, they are talking about a batch process. Another good example of batches, let's say for example this is a banking application. I'll just put B for banking. Okay, banking. Right. This is a banking application. And then there's a lot of mortgage loan application sitting over here. Okay. So every day a lot of mortgage application comes up. So towards the end of the day, so every day if it's a bank like US Bank or Bank of America or Chase, there is thousands of applications that's coming up every day. Right. Now, whether these applications are getting approved or rejected, it is not decided by a human being. There is absolutely no human intervention, at least in North America. No human intervention. It's all done by a process called orchestration, which we'll discuss later. I don't want to go into this topic because it's kind of, I don't want to overload with information. But then just think of it like this. This process, this orchestration process will decide whether your mortgage loan application is getting approved or rejected. Okay, just think of it like that. Okay, this is a process that will decide whether your mortgage loan application will get accepted or rejected, right? So every day at 12 a.m. a batch will run, and it will take one application and feed it into the orchestration process. It will give a decision. It will get housed in another table. Then another application will come, then another application will come, and then it will go here. Orchestration process will happen. Yes or no decisions will be given, and it will just go on. It will be present in this table. Every day at 12 a.m. only this will happen. This is called, so it's just picking up and putting it here, right? This is called batch process. In a nutshell, processing humongous amount of data in regular interval of time. So the batch can be manually triggered if you tweak the code, but in general, it's going to happen at a certain time. That's how it's used generally. So at any point when they say at 4 p.m. this batch will run, this is what they are talking about. All it's doing it's picking up some data and dumping it into another source. This is what it's doing. It's done in an automated way, and then it's processing humongous amount of application. So that's what is happening. So any questions on the batch process?
Yes, like creating a batch file and forwarding that to a kind of human in there. That's the process, or human feeding a batch file to the system.
So the batch will be coded. So it will be coded in the middle tier. The batch process, when I say batch process, when you ask how it is happening, it is coded in the middle tier. Okay, that is where the code is sitting. But then as part of batch, what happens is there are many entries. So these are all number of employees left. So let's say on a Monday, 7, Tuesday, 4, Wednesday, 5, likewise 8, 9, 11, 2, 0, right? Now, so Thursday or 1st of Jan, 2nd of Jan, 3rd of Jan, 4th of Jan. So towards the end of 10 days, so there is around so much entries here, at least 10 entries here, right? So now a batch will run. It will take all these data. Let's say there's going to be So if there are 7 entries, there's actually going to be 7 rows. I just want to show it properly. If there are 7 entries, there's going to be 7 rows, right? It is going to have names of employees. This is how it will be. When I say table, it's going to be like this. It's going to have a table. It has to have a name, employee ID. So reason why left, reason left. And there's going to be, and then so I don't know, salary. So all that info, all other info is here, okay? So now employee number. There are around 1,000 entries. If it's a very big factory, there's going to be 1,000 entries per month, let's say. So, 500 entries, okay, per month. They have so many branches all over the globe. Let's assume like that. Now, a batch will pick up around 1,000 entries. Each and every, so 1, 2, 3, 4, 5, 6, till 1,000 entries are there. So every month there's going to be 1,000 entries in this table. I want to transfer this into another application, which is a governing body. That is a separate application. It has to go into that table of the governing body. So I cannot transfer it one by one. On every month, I cannot tell somebody to write query and transfer the data. Makes no sense, right? Somebody has to, every month on a certain day, somebody has to write some queries and make sure it's sitting here. No. Instead of that, what we can do is we can code for a batch process. Every month, first day, 12 a.m., it will just pick all the entries and it will dump it into this table in the external data source. That is what it does. That's all batch does. How is it coded? It is coded in the middle tier. Sometimes backend is also involved, but then it happens in an automated way.